Sorry if this seems like I'm going real fast, but they like me to keep it to 7 minutes on each topic. So I've done some notes ahead of time. When we're eliminating a variable, we want to see something like this. This is beautiful right here because those two variables are opposites of each other. So I can immediately switch to addition. I don't have to do any manipulation to either of those two equations before I add them together. When I do, I get 2x on the left and 10 on the right. Dividing by 2 obviously gives me an x value of 5. Now, does it matter which equation I plug the 5 back into to find out what y is? Absolutely not. 99 out of 100 kids would pick the one that has the most positives in it. They don't want to mess with negatives if they don't have to. And so you can easily see if we move this over, we get y equals 1 minus 5 is negative 4. So we know that 5, negative 4 is the place where these two lines cross. You can plug that back in and you can verify. When you add 5 and negative 4 together, you do get 1. And when you subtract 5 and negative 4, you do get 9. So it works when you plug them back in. Question 2. Solved by the elimination method. Okay, you notice the really nice thing going on right there. So you can immediately add, getting you 10x equals 80. Dividing by 10 on both sides tells me that y is 8. Pick your favorite equation. It really doesn't matter. I picked the bottom one, but you can do anything you want there. The reason I did was because y was by itself, but you know, makes less multiplication to worry about. Of course, you're going to push this to the other side. 36 take away 8 gets me to positive 28. And dividing by negative 4 gets me to negative 7. So we know that negative 7, positive 8 is the coordinate where the two lines cross. Move it on to the next one. Beautiful things are happening, right? I love it when we see those kind of things because that means when we add them together, those disappear and give me 6x equals 18. A little division by 6 gives me an x value of 3. Pick your favorite equation. I just chose the top one. It doesn't really matter to me what you choose. Plug that in. That's 6. If I take 6 away from the other side, I get 0. And 0 divided by 12. Don't tell me that it doesn't exist. That is a big fat 0. 0 in the numerator means the whole number is 0. Now 0 in the denominator, that's a big problem, right? Because now we're talking about something that doesn't exist. So 3, 0 is the place where those two lines cross, right on the x-axis. Next question. Okay, you'll notice here in this question number 4 that we didn't have any beautiful setup in the beginning. So I focused my attention right here and I said, wait a sec. What if I multiply the bottom equation by 2? Now, if you do it, you'll notice that I put parentheses around the whole thing because I'm trying to indicate to you that I'm going to multiply the bottom equation, the entire thing, left and right side of it, by 2. Well, that's going to change it into 4x minus 2y equals 10. All right, you must multiply the whole equation. If you don't, you will end up getting a wrong answer. Well, look right here. They cancel out. When you add them together, you end up with 7x equals 28. Divide by 7 on both sides, and we know that x is 4. Okay, so pick your favorite equation to plug x back into. So I'll pick the top equation. 3 times 4, that's 12. If I take 12 away from the other side, that gives me 2y equals 6. So now I can divide by 2. And I can find out that the y value is 3, and that is a positive 3. So we have 4 for x and 3 for y. So the coordinate 4, 3 is the solution. All right, moving on. What happens if you see the cool thing going on and you're like, yes, I'll add them together. Wait a second. Well, those canceled out too, and those canceled out too. That leaves me nothing on the left side of the equal sign. But when I add those two, 10 and 10 together, I get 20. So here's my question to you. When in your life has 0 been equal to 20? Sometimes, always, or never. Now, I'm hoping you said never. So that's telling me that there's no solution. Now, we know that no solution means that these are parallel lines. Wow, my A's are really looking bad there. Parallel lines. So, that's the situation we're in for this question. All right, let's move on to the next question. What happens if there's not just one number I need to multiply by? What if the x's don't have, there's nothing cool for the x's to use, there's nothing cool for the y's to use? So I focused my attention right here. I wanted to make them either 30y or negative 30y. So I chose to multiply the top by 5 and chose to multiply the bottom by 6. Sorry for yawning. I hope I don't continue to do that because I know nobody likes that. And if you distribute the 5 all the way through, you get, you get this equation up here, 25x minus 30y equals 75. And if you distribute the 6 across the bottom, you end up with the other one, 36x plus 30y. And the cool part is right in here, right? Those are going to disappear, right? And then you add all your x's, you get 61x. And if you add your constants, 75 and 474, you get 549. And if you divide by 61, oh my goodness, we get 9. Pick your favorite equation. I picked the bottom one because it only had positives. But it doesn't matter. You can pick the top one if that makes you feel better. It works. It'll work just as well. So 6 times 9 is 54. So I'm going to bring the 54 to the other side. 79. Take away 54. Will that be 29? Take away 4 is 25. And now I can divide by 5. And I can find out that the y value is 5. So 9, 5 is the solution. That's where they cross. Got one more to go here, and then we'll be done with this particular lesson. And so I looked at it, didn't have anything cool, so I said, all right, let's go with this. We're going to multiply that top equation by negative 4x. I'd like you to notice something. Try to zoom in here. You can see what I did here, and let me clear that other marking out here. I wrote the multiplied version of the equation directly above it. So I wrote that multiplied version straight above it. And then I drew this kind of connector together, indicating that I'm going to add those two equations together. Now you notice that the x's got eliminated, but the y's also got eliminated. And then we ended up with 7 on the other side. So we're looking at a situation where we have to decide, is that sometimes true, always true, or never true? Of course, in this case, that's never true, so there is no solution. Now, when would you end up with an always true? An always true would end up happening if you got like 0 equals 0. It would also end up if you ended up with like 5 equals 5. Or 17 equals 17, something like that, where the answer to where there's no x's and there's no y's, but you have the same number on both sides of the equation. That would be an always situation. Never is when they don't equal each other. There's no x's, no y's, and they don't equal each other. Okay, thanks for the extended video time.